Hey guys, in this lesson we would go over the next two rules of derivatives. That includes quotient and chain rule. First we're going to understand what is quotient rule. If we have a function written as fx equal to a quotient of px and qx, then the quotient derivative rule says that we need to find the derivative of the numerator, times it by the denominator, subtract it with the derivative of the denominator, times it by the numerator, and the whole thingy divided by the square of denominator. Let's understand this with an example. Let's say if we have fx is equal to 2x minus 1, the whole thing divided by 4x, then the numerator is going to be called px, denominator is going to be called qx. In this case, derivative is going to be equal to derivative of the numerator, that is 2x minus 1, times the denominator, minus derivative of the denominator times the numerator, and the whole thing will be divided by 4x squared. We don't have to leave it here, we need to simplify it further. Now when we need to find the derivative of the numerator, we apply the difference rule that we had learned in the previous lesson. The derivative of the 2x will give us a 2. The derivative of a 1 is going to give us a 0 times 4x, minus the derivative of 4x is going to give us a 4 times 2x minus 1, the whole thing divided by 4x squared. This would give us 2 minus 0 is a 2 times 4x minus 4 times 2x, we can use distributive property, will give us a negative 8x, minus 4 times negative 1 is going to give us a plus 4. The whole thing divided by 4 squared is 16x squared. This would give us an 8x minus 8x plus 4 over 16x squared. When we simplify this further, we will be able to get a 4 out of 16x squared. That will be 1 over 4x squared. So this is the derivative of the original function that was given to us as this. Hence we can write on the final answer as f prime x is equal to 1 over 4x squared. Here we need to remember one thing. This is a general derivative equation, or this is the general derivative formula for the given function fx. If in case we are asked to find the slope at a given x value, for example, if we were asked to find the slope at x equal to 3, in that case we would sub in x as 3 in the derivative equation, and that would give us a 1 over 36 answer. So the slope of this particular function fx at x equal to 3 is 1 by 36. The next rule that we have to discuss is called the chain rule. Chain rule is applicable when we have a function equal to another function px that has a power on it. So in this case the derivative can be written as n times, instead of putting a multiplication sign, we'll just put a dot here, px to the power of n minus 1 times the derivative of p again. Let's understand this with an example. If we have fx is equal to any function 3x squared plus 2x minus 1, and the whole has a power n, it could be any real number, let's say it's 5, then the derivative can be written as 5 times 3x squared plus 2x minus 1 to the power of 5 minus 1 times the derivative of 3x squared plus 2x minus 1. When simplified further, it would give us 5 times 3x squared plus 2x minus 1 to the power of 4 times, because this whole bracket has a derivative sign on top of it, so we're going to simplify each term inside the bracket individually and apply the sum and the difference rule of derivatives to this bracket. And this would look like 3 times 2 times x to the power 2 minus 1 plus 2 times 1 times x to the power 1 minus 1 minus the derivative of a constant is a 0. This would give us 5 times 3x squared plus 2x minus 1 to the power of 4. So the result that we get is 5 times 3x squared plus 2x minus 1 to the power of 4 times 6x plus 2 minus 0 we don't have to put, and this is how we can leave our final answer for the derivative equation. If in case we were asked to determine the derivative at a given x value, for example at x equal to 3. Then we would just simply sub in x as 3 into the derivative equation and solve for the function. So this would give us 3 squared times 3 is 27 plus 6 minus 1 times 18 plus 2. When we simplify this further, we would get 3200 as the slope of this given function at x equal to 3. Okay, next we would understand what happens if we are supposed to apply chain rule with the product or quotient rule. We'll take up an example of chain rule with the product rule. If we have fx is equal to 3x cubed minus 2x squared, the whole thing to the power of 5, times x minus 1 to the power of 3. Now we notice here that this function is a product of two functions, where each function has a power n on top of it. So it is a combination of a product and the chain rule. How we proceed towards solving this type of a problem is, we would have the derivative function equal to the derivative of the first part of this function, and we can write it with a prime sign, times, forgot to put a 5 there, times x minus 1 to the power of 3 plus the derivative of x minus 3 to the power of 3 times 3x cubed minus 2x squared to the power of 5. We're not supposed to leave it here, we have to simplify it further, and that would be, the power is 5, so we're going to apply the chain rule here. That is 5 times 3x cubed minus 2x squared to the power of 5 minus 1 is 4. And we're going to rederivate the bracket that contains 3x cubed minus 2x squared times this, plus the derivative of this is going to give us 3 times x minus 1 to the power of 2 times the rederivative of this. This whole thing will be multiplied by this. When we simplify it further, we would be able to get 5 times 3x cubed minus 2x squared to the power of 4. Inside we would have 3 times 3, 9x squared minus 4x. Now we don't have to put the prime sign as we have already found out its derivative, times x minus 1 cubed plus 3 times x minus 1 squared. The derivative of x minus 1 is a 1. Then we rewrite 3x cubed minus 2x squared the whole to the power of 5. Now in order to write the final answer needs to be in factored form. So we notice we have two terms here. This is one term, this is the second term. We would be finding out what are the common factors in these two terms. And we clearly notice that we have one is x minus 1. And the other common factor we notice is 3x cubed minus 2x squared. Although they have different powers, so that's what we're going to be factoring out. So from the first bracket, that is this term, we're going to be taking out 3x cubed minus 2x squared. This has a power 4 and this has a power 5. We always take out the smaller power. So we're going to put this out. And then from x minus 1, this has a power 3, this has a power 2. We're going to write down the one with power 2. So we would be left from the first term, that is this term, of 5. This is all gone. 9x squared minus 4x. And one of this is left because we only took out 2 common. So we would have x minus 1. Plus, from the second term, we are left with 3. This is all gone. 1 we don't have to write down. So we are left with one of this because this is 5 and we only took out 4. So we would have 3x cubed minus 2x squared to the power of 1. We don't need to put that. And finally, we can leave this as a final answer. Or we just notice that we have an x common in both of these terms. So we can even take out that x as a common factor outside. So if we do that, we will be left with 3x cubed minus 2x squared the whole to the power of 4 times x minus 1 squared. When taking out one x common, we will be left with 5 times 9x minus 4 x minus 1 plus 3 times 3x squared minus 2x. If we want to further simplify it, we can expand this using distributive property as well as this. and then we can collect the like terms, or we can leave here as the final answer.